Hi, my name is Alexander Savic, one of the architects on the Coherence engineering team. In this presentation, I will talk about new asynchronous name cache API that was introduced in Coherence 12.2.1. So let's look at the first demo, which shows some basic get and put performance differences between synchronous and asynchronous API. So I have two cache servers already running, and I'll start a test because it will take a minute or so to run, and then I'll walk you through the examples. So while this is running, these are basically our tests. We're doing test for asynchronous put. This is the test. We create an array of 1,000 completable futures. We will do 1,000 individual cache async put operations. And what we are putting in is this binary, which is created here, which is basically just a 1 kilobyte big binary object. And then we'll run this test 100 times and report the results. So yeah, it will do 100 iteration warm up, and then it will run the test itself 100 times and time it and report average for the 100 runs for the test itself. Keep in mind that the result that's reported is actually for 1,000 asynchronous puts. And the same thing for synchronous put. The code here is very similar, except we don't have to do anything with completable futures. So the code is do 1,000 synchronous puts in a loop. And then same thing, we'll run it 100 times, report the results. Similar thing for asynchronous get. We have completable futures, we run it 1,000 times. We wait for all futures to complete to make sure that we are not reporting results for things that haven't completed yet. And we do the test. And similarly for synchronous get, populate the cache, define the test that we want to run, and run it 100 times. So this is basically what do test does. It will run the warm-up loop, it will run the actual test loop, and then report the duration that it took per iteration, and the throughput in thousands of operations per second. This takes into account that we are doing 1,000 gets or 1,000 puts in each iteration. So let's take a look at the results. As you can see here, synchronous put took almost 200 milliseconds per iteration, and which gives us about 5,000 puts per second. Asynchronous put, on the other hand, took 27 milliseconds per iteration, or 37,000 puts per second. Synchronous get, 100 milliseconds, or about 9 to 10,000 operations per second. Synchronous async get, 22 milliseconds, or 45,000 per second. And the results will be slightly different based on each test run, but in general, async get and put both are around between 20 and 25 milliseconds, and sync put is about 10 times slower, about 200 milliseconds, and sync get is about 5 times slower, about 100 milliseconds. So those are the results that I was getting fairly consistently, even on much longer runs than this one. So let's switch back. And basically that's what this table captures. We're doing 1,000 individual gets or puts with 1 kilobyte object using one test client, 2 cache servers on my laptop, which is 2013 MacBook Pro with Core i7, 2.7 gigahertz and 16 gig of RAM. And the results that I got on the test, on the particular test that I used to capture information in the slide, I had this is divided by 1,000 for the 1,000 individual gets and puts. So I have 94 microseconds per get, or about 10,000 gets per second, and about 200 microseconds or 5,000 puts per second for the synchronous API, and then 22 microseconds or 45,000 gets and puts per second for the asynchronous API. In this case, both took about the same amount of time. So as you can see, we're doing the asynchronous gets are about 4 to 5 times faster than synchronous gets, and asynchronous puts are about 9 to 10 times faster than synchronous puts, which is significant improvement.